Partial differential equation of first order. Objectives of this unit are as follows. First one, to define first order partial differential equation. Second objective, to classify a partial differential equation into linear and non-linear. Third objective, to study the method of solving non-linear partial differential equations. Now, definition of a partial differential equation of first order. A differential equation containing one dependent variable and more than one independent variables and also involving first order partial derivatives is called partial differential equation of first order. If suppose z is a function of two variables x and y, then its first order partial derivatives are denoted by dou z by dou x and dou z by dou y and are also denoted by symbol p and q respectively. That is, p equal to partial derivative of z with respect to x and q equal to partial derivative of z with respect to y. The general equation of the first order partial differential equation with one dependent variable, say z, and two independent variables, say x and y, is represented by a function of p, q, x, y, z is equal to 0. This is equation 1 we can denote. Now, what is meant by complete solution of a partial differential equation? A functional relation between variables x, y and z containing two arbitrary constants, say a and b, which satisfy the partial differential equation given in equation 1 is called complete solution of that partial differential equation. Now, what is meant by particular solution? The solution which is obtained from the complete solution by giving particular values to arbitrary constants is called the particular solution. Now, classification of a first order partial differential equation. The first order partial differential equations are classified into two categories. First one, non-linear partial differential equation and linear partial differential equations. What is meant by non-linear partial differential equations? A partial differential equation which involves first order partial derivatives p and q with degree other than 1 and may involve product of p and q is called non-linear partial differential equation of first order. Example, see, first one, root p plus root q equal to 1. Second example, p into q plus q equal to 0. Third one is p square minus q square equal to z. These all are non-linear partial differential equations because in first equation and in last third equation, the degree of p and q is other than 1. So, these two are belongs to non-linear partial differential equation. And in second equation, there is a product between p and q in the equation, so that it is also called as non-linear partial differential equation. Now, what is meant by linear partial differential equation? A first order partial differential equation is said to be linear if degree of partial derivatives p and q is 1 and they are not multiplied each other. Look at this equation. X square into p plus y square into to q is equal to z square. In this partial differential equation, the degree of p and q is 1 and p and q are not multiplied each other, so that it is a linear partial differential equation of first order. Now, how to find the solution of non-linear partial differential equations? The solution of non-linear partial differential equations are restricted to the following standard forms. There are so many forms are there, but here the solution of non-linear partial differential equations are restricted to the following three standard forms. In standard form number 1, f of pq means the variable x, y, z absent in the equation. Standard form number 2, f of z pq equal to 0 means here x and y two variables are absent. And standard form number 3, function of px equal to function of qy. In this, variable z is absent. Now, how to find the solution of a partial differential equation of a first order belongs to standard form number 1 we are learning in this lecture. Method of finding the solution. In this standard form, the equation containing only p and q and no variables x, y and z. For this standard form, let us assume the complete solution of equation is z equal to ax plus by plus c, and this is the equation number 2. When we differentiate z partially with respect to x and partially with respect to y, we get value of dou z by dou x which is equal to a and dou z by dou y which is equal to b. That is p equal to a and q equal to b. When we substituting the value of p and q in equation f of pq equal to 0, which is a given partial differential equation, we get f of a comma b is equal to 0. This is the equation number 3. From equation number 3, we can find value of b in terms of a or value of a in terms of b. Let us suppose value of b is equal to psi of a. Then substituting the value of b is equal to psi of a in equation 2nd, we get z equal to ax plus psi of y into y plus c, where c is the constant and a is also constant. This is the required solution of a partial differential equation of first order which belongs to standard form number 1. Now illustrations. Example number 1. Solve the partial differential equation p square plus q square equal to 1. Look at this equation. There is no x, y and z. So this partial differential equation belongs to standard form number 1. So let us denote this equation by equation 1. So by method, assume the complete solution of this equation 1 is z equal to ax plus by plus c and denote this equation by equation 2. When we differentiate this z with respect to x partially and with respect to y partially, we get p which is equal to dou z by dou x is equal to a and q equal to dou z by dou y is equal to b. Substituting the value of p and q in equation 1, we get a square plus b square equal to 1. And from this equation, we can find value of b in terms of a, that is b equal to root 1 minus a square. Putting the value of b in equation 2nd, we get z equal to ax plus root 1 minus a square into y plus c, which is the required solution of given partial differential equation 1. Now another example. Solve partial differential equation p into q is equal to p plus q. Again it belongs to standard form number 1, and let us denote this partial differential equation by equation 1. Again, assume the complete solution of this equation 1 is z equal to ax plus by plus c. It is equation number 2. From equation number 2, when we differentiate z with respect to x partially and with respect to y partially, we get dou z by dou x equal to a, which is b equal to a, and dou z by dou y equal to b, which is q equal to b. Substituting the value of p and q in equation 1, we get a into b equal to a plus b. From this, we can determine b in terms of a, that is b equal to a upon a minus 1. Putting the value of this b in equation second, we get z equal to ax plus a upon a minus 1 into y plus c. So this is the required solution of given a partial differential equation. Now assignment. Question number 1. Classify the following into linear and non-linear partial differential equations. Here we are given 4 partial differential equation of first order. We have to classify how many of these are belongs to linear and how many of these are belongs to non-linear partial differential equation. Now question number 2. Solve the following partial differential equations. Now knowing the method of solving the partial differential equation belongs to standard form number 1, you can find the solution of these examples.